Okay, so we're gonna go ahead and get started. If you do go ahead and jump on while I'm working, just let me know if you have any questions. So this is the Math 123 review for practice test 3. So this is the end of semester assessment. So keep in mind that the material here is only from Unit 3, but there could potentially be questions from Unit 1 and Unit 2. You'll want to refer back to the homework, the notes, and to the practice quiz that's online for this practice test. One thing to keep in mind is not only are you allowed to use your calculator for this assessment, but you're also allowed to use your yellow sheet. This is the conversion and formula sheet that will help you answer some of these questions. So this first set of questions, these conversions, are found in Unit 3 or in Section 13 on conversions. So this is the factor label method. So for example, here it says the height of Mount Everest is 29,035 feet, and they want to know how many miles is that. So I would start with my conversion, with my, what I'm starting with, my 29,035 feet, and I would put that over 1, and I'm going to multiply by, we do have a direct conversion that goes from miles to feet. We know that 1 mile is 5,280 feet, so that's the conversion that I'm going to use. 1 mile, 5,280 feet. Remember, when using the factor label method, whatever unit you start with, you want it to be on the diagonal, and whatever unit you're converting to, you want it to be opposite. So that way, when I go through and complete this, the units will cancel, and we end up with 29,035 divided by 5,280, which is equal to which is approximately equal to 5 points. So notice we've got 5 significant digits, 4 significant digits. So we're going to go with the 4. So it's 5.499 miles. Okay. Next up. So the next conversion starts 10 kilometers. They want us to convert that to miles. So again, I'm going to start with 10 kilometers over 1. And I'm going to refer to my yellow sheet. Now notice in my yellow sheet, we do have a conversion that's 1 mile is approximately 1.6093 kilometers. So that's what I'm going to use here. So I'm going to use, we're converting from kilometers, that's going to go in the denominator. We're converting to miles, that's going to go in the numerator. It's 1 mile, 1.6093 kilometers. So this ends up being 10 divided by 1.6093 kilometers. So when we do that division, and we round our answer using significant digits, we end up with approximately 6.2 kilometers, or 6.2 miles, not kilometers, sorry, wrong unit. Okay, so 6.2 miles. All right. So next up, so the next one says you buy a 24 pack of 591 milliliters of bottles of water. How many liters is that? So there's 2 ways that you can do this. One, you could take the 24 times the 591 milliliters, to get 14,184. So there's 1,184 milliliters of water altogether. So if you use the idea that milli is 1,000, so there's 1,000 milliliters in a liter. So we can multiply that by 1 liter over 1,000 milliliters, and that would get us 14.184 liters. Or if you use the yellow sheet, So if I know there's 14184 milliliters, I go to my decimal. To go from milliliters to liters, we go 1, 2, 3 to the left. So we can go 1, 2, 3 to the left, and that gives us an answer of 14.8184 liters. So same answer, two different ways of going about doing it. Okay. So next up, now it says how many pints are there in 15 gallons? So I start with my 15 gallons. I'm going to put it over 1. There's no direct conversion from gallons to pints. So we have to go gallons to quarts, then the pint. So in this case, we know that there are 4 quarts in a gallon. So it'd be 4 quarts, 1 gallon. And then we know that there are 2 pints in a quart. So then notice that gallons cancels, quarts cancel. We multiply straight across. 15 times 4 is 60. 60 times 2 is 120. So we end up with 120 pints. All right, so next up. So now we're talking about a drug bust in Shanghai. Police seized 2.4 tons of methamphetamines. If a typical dosage is 50 milligrams, how many doses is that drug bust, which the Chinese police prevented from being sold to the public? So notice that we start with 2.4 tons. And notice that we want to go to milligrams. So what we're going to have to do here is we're going to go from tons to pounds to kilograms to milligrams. So we would do 2.4 tons. We know there's 2,000 pounds and 1 ton. That's from the yellow sheet. Then we know from the yellow sheet that there is 0.4536 kilograms per 1 pound. Then we also know that there are 1,000 grams per 1 kilogram. Then we know that 1 gram, or that there's 1,000 milligrams in 1 gram. And then we also know that 1 dose is 50 milligrams. So when I multiply straight across, we end up with 2.4 times 2,000 times 0.4536 times 1,000 times 1,000 divided by 50. So in that 2.4 tons, the police stopped 43,456,000 doses from being sold to the public. 43,456,000 doses. Let me double check that number. So 2.4 times 2,000, that's 4,800 pounds times 0.4536 times 1,000 grams in a kilogram times 1,000 milligrams in a gram. Yeah, and then divided by 50. Okay, so that does work out. Okay, next up, a 52-inch wide TV has a screen area of 1,064 inches squared. How many square feet is this? Okay, so 1,064 square inches. So that's inch times inch. So what I can do here with this And it depends on how you want to approach it. So we know that to approach this, I've got to do the inch to foot conversion twice because it's square inches. So we know that 1 foot, 12 inches, and we're going to multiply by that conversion twice. So it's going to be 1,064 divided by 144 square feet. So I do 1,064 divided by 144, and we end up with 7.39 square feet. So the area of the 52-inch wide TV is 7.39 square feet. Okay. Now, for number 5, water's coming out of the hose at 20 quarts per minute. How many gallons per hour is this? So I have 20 quarts per 1 minute. I'm going to go quarts to gallons. So we know that there's 4 quarts in a gallon. We know that 1 gallon is 4 quarts. Now here's where this one gets a little tricky. I've got minutes in the denominator. So because I've got minutes in the denominator, I've got to put minutes in the numerator, hours in the denominator. And we know that there's 60 minutes per hour. So when I multiply 20 times 60, that's 1,200. 1,200 divided by 4. So that's 1,200 gallons in 4 hours, which is the equivalent of 300 gallons per hour. So the water will come out of the hose at approximately 300 gallons per hour. Okay. So next up, we go to page 2. We look at question 6. So question 6 says you're constructing a rectangular concrete patio that measures 10 feet by 6 feet by 10 inches. What's the volume in feet cubed? What is the volume in meters cubed? Okay. So to calculate volume, first things first we need to do here is we need to calculate each unit as the same. So we've got feet, feet, and inches. So there's 2 ways that you can do this. One way would be to convert inches to feet or convert feet to inches. Well, because they're asking us to do cubic feet, we would take the 10 inches and I would convert that to feet. So I would use the conversion factor that 1 foot is 12 inches. So when I do that multiplication, we end up with 10 over 12 feet, which is 5/6. I'm going to leave it as 5/6 only because of these 2. It makes it easier to cancel and work with. So remember that volume of a rectangular prism or a rectangular concrete patio is length times width times height. So it's going to be 10 times 6 times 5/6. And that's going to be in cubic feet. So when I multiply, we end up with 60 times 5/6, which is 50. So the volume of the concrete patio is 50 cubic feet. So now we have to convert that to meters cubed. Well, we don't have a direct conversion from feet to meters. We do have a conversion from meters to yards. So that's the direction that we're going to have to go in here. So I would take my 50 cubic feet and I would multiply it by 1 yard over 3 feet 3 times. And then I would multiply that by the fact that there's 0.9144 meters in 1 yard. And I would multiply by that 3 times. Because again, we're working with cubic feet. Okay. So it'd be 50 divided by 27 times 0.9144, which gets us approximately 1 point, I will call that 42 cubic meters. So 1.42 cubic meters. All right. Next question, number 7. So you order a 1-pound steak in Indianapolis, but pounds are not used in Australia. Please convert pounds to ounces, then to grams, so you can order steak in Australia. Now, in this one, they do give you the conversion. They tell you that 1 ounce is 28 grams. So you're going to do that at the very end. So you start with your 1 pound, and the conversion for pounds to ounces, there's 16 ounces in a pound. And then we would multiply that by 28 grams over 1 ounce. So when we multiply, we end up with 448 grams, approximately. Therefore, a 1-pound steak in Australia would be 448 grams. Okay. So next up, dosage calculation. So we have a medication for diabetes that has a dosage of 10 milligrams per kilogram per day. That's the limit. And you're not to exceed that recommended dosage in a 24-hour period. It is to be given 2 times per day. If an adult weighs 220 pounds, what is the maximum dosage that he or she should receive rounded to the nearest milligram? Okay, so we're going to start with the weight. So we're going to start with our 220 pounds, and we're going to convert that to kilograms. So we're going to multiply that by 0.4536 kilograms per 1 pound. Then we're going to multiply it by the dosage. So the dosage is 10 milligrams per 1 kilogram of body weight. And that will tell you how many milligrams the person could receive as a maximum dosage. So 220 times 0.4536 times 10. So this person can receive 997.92 milligrams per day. So this is per 1 day. So now we would multiply that by 1 day over 2 doses. So this would be approximately 498.96 milligrams per 1 dose. So notice it says to round this to the nearest milligram. So if I rounded this to the nearest milligram, it'd be 499 milligrams. Therefore, this person can receive 499 milligrams per dose for this particular medication. All right, number 9, if your car gets 24 miles per gallon and you drive 420 miles, how many pounds of CO2 would be produced on your trip, assuming that it's 19.8 pounds per gallon of CO2? So with this one, you would start with the 420 miles. You would multiply by the fact that there's 1 gallon for 24 miles. That's your gas mileage. Then you would take that and multiply it by the 19.8 pounds of CO2 per 1 gallon of gas burned. So if we do 420 divided by 24 times 19.8, we end up with 346.5 pounds of CO2 produced on that trip. Okay, number 10. I think we're about halfway home. Okay. So number 10, every night you turn on a portable fan for background noise while you sleep. If you leave this 100-watt fan on for 8 hours per night, how many pounds of CO2 will you produce in a year? And that's assuming that there's 1.37 pounds of CO2 per kilowatt hour. Okay. So the first thing we have to do is we have to take this 100 watts and we have to convert it to kilowatts. So remember that 1 kilowatt is 1,000 watts. Then we have to take this and multiply it by the amount of time that it's on. So we're going to multiply this by 8 hours. When we do that, that now gets us in the kilowatt hours. So then the final step, once we do that, would be to multiply by 1.37 pounds CO2 per 1 kilowatt hour. So 100 divided by 1,000 times 8 times 1.37, 1.096 pounds CO2 produced. So leaving that fan on for 8 hours a night is going to produce 1.096 pounds of CO2 per day. So 8 hours per 1 day. So now we have to take that 1.096 pounds of CO2 per 1 day, and we have to multiply that by 365 days in 1 year. Because the question said, how much would you produce in a year? So when I do that multiplication, we end up with 400.04 pounds CO2 produced in 1 year. So again, the big thing is making sure that you read the directions. Because a lot of people will leave it as this and they'll say they're done. This is per day and they want it to know per year. All right. Question 11. Question 11 says create a bar chart for each column of data and compare. So notice they give us 2 columns. They give us the number in thousands and they give us the percentage. So when I come over here, I do Indiana's bar, I go up to approximately 1126. Illinois is approximately 1804. Ohio is approximately 1788. And Kentucky is approximately 849. That's the first bar. Then I do the percentages. So Indiana is approximately 23.1%. Illinois was approximately 18.6. Ohio's 20.3, and Kentucky is 25.6. Okay. So this is census data. So what do we notice here? Well, we notice that based on just the number alone, that Illinois has the highest at 1804. That's in thousands. So that's 1,804,000. Kentucky has the lowest. But if we look at percentage-wise, come to find out, Kentucky actually has the highest percentage of smokers in the state population, while Illinois has the lowest percentage. So even though Illinois may have more smokers than Kentucky, based on population, Kentucky has the highest percentage of the population that's smokers, while Illinois has the lowest. So that would be something that you would write to describe the data. Okay, so next up, now they want you to briefly explain the following. So the first thing they want you to briefly explain is normal distribution. So normal distribution comes from a histogram. So when we create a histogram based on large amounts of data, the graph will start to form this bell-shaped curve. So this bell-shaped curve that's formed is called a normal distribution curve. So what do we know about a normal distribution? Well, we know that the mean, the median, and the mode are all equal. We know that the curve itself is symmetric. That means if I were to fold it in half, it would be the same on both sides. And we know that 50% of the values are less than the mean. We know that 50% of the values are above the mean. All right, so next up, now they asked us to briefly explain standard deviation. So standard deviation measures the amount of spread from the mean. So how's the data spread out as it deviates from the mean? That's what they're talking about there. So then the third one is the empirical rule 68, 95, 99.7. So again, that rule tells us that approximately 68% of all the data values are within one standard deviation of the mean. Approximately 95% of data values are within two standard deviations of the mean, and 99.7% of data values are within three standard deviations of the mean. Okay. So we're actually going to use the empirical rule 68, 95, 99.7 rule to help us answer question number 13. So you're told that the weight of a package of Oreos is normally distributed with a mean of 518 grams. The standard deviation is 4 grams. What is the range of weight in a package of Oreos that is 68%? So to calculate this, we would do 518 plus or minus 4. So when I do 518 minus 4, that's 514, and we do 518 plus 4, that's 522 grams. So the range of the weight of a package of Oreos within 68% is between 514 and 522. So for the 95%, we'd go 4 below and 4 above again. So this time I would do 514 minus 4, and I would do 522 minus 4. That's 510, or plus 4, and 526. So the range of a weight of a package of Oreos that's within 95% is anywhere between 510 and 526 grams. So then for the 99.7 rule, again, that's within 3 standard deviations. So essentially, we're going to subtract 4 and add 4. So if I do 510 minus 4, that's 506. And if I do 526 plus 4, that's 530. So therefore, all the Oreos, 99.7% of packages of Oreos would fall between 506 and 530 grams. Okay. All right. Question number 14. So based on the data 2009 statistical abstract of the United States, the average American generates 1,700 pounds of garbage per year. This is a normal distribution with a standard deviation of 200 pounds. So the first thing they're going to ask us to do is they're going to ask us to draw and label the curve. Okay. So remember that the mean, mu, always goes in the center. We know that's 1700. The standard deviation is 200. So as we go up, we add 200 each time. So 1900, 2100, 2300. As we go down, we decrease, we subtract. So 1500, 1300, 1100. So now they want us to calculate the z-score and find the probability for somebody that generates up to 1,300 pounds of garbage. So we're going to let x equal 1,300 pounds of garbage. So remember to calculate z-scores, we use the formula z equals x minus mu divided by sigma. So x minus the mean divided by standard deviation. So this would be 1,300 minus 1,700 divided by 200. So we end up with negative 400 divided by 200, which gives us a z-score of negative 2. So then we go on our chart on the back, we go to a z-score of negative 2, and that is 0.0228. So 0.0228. 2.28%. So the probability is 0.0228. That means that there is a 2.28% probability of someone that generates up to 1,300 pounds of garbage in a year. Okay. So now the question says, find and calculate the z-score, find the probability that someone generates more than 2,000 pounds of garbage. So this time we want x to be greater than 2,000 pounds of garbage. So keep in mind, remember that when we find a z-score to find probability, so here's our 2,000. That's going to find everything to the left. So if I wanted to find everything to the right, I would have to calculate this probability and do 1 minus. So we would calculate the z-score for 2,000. So 2,000 minus 1,700 divided by 200. So we end up with 300 divided by 200, which is 1.5. So the probability in that case, if I go to 1.5 on my chart, that's 0.9332. That would represent the probability of everything to the left. I want the probability to the right. So to find this, we have to do 1 minus 0.9332 to get a probability of 0.0668. So there's a probability of 0.0668, 6.68% chance that someone would generate more than 2,000 pounds of garbage in a year. Okay. So on to question number, that was 14. Let's go to question 15. So question 15, the mean for men age 60 is 29. The mean BMI for men age 60 is 29 with a standard deviation of 6. What percentile of or weight is a man whose BMI is 32? Okay. So the mean, this is our mu, standard deviation. This is our sigma, 32. So we're going to let x equal 32. So we have to calculate a z-score. So z equals x minus mu divided by sigma. We end up with 32 minus 29 divided by 6. That ends up being 3 divided by 6, which is 0.5. So when I look up 0.5 on my chart, it ends up being 0.6915. So the probability is 0.6915. So again, the question always is do we round down? Do we round up? Well, in this case, we would look at this as 69th percentile. So this gentleman is in the 69th percentile for BMI. All right. Question 16. So for question 16, a new iPad got the following ratings and stars on Amazon.com. If the present ratings of this iPad remain consistent, what is the probability that it would receive a future rating of at least 4 stars? So at least 4 stars, that means calculate, we have to add 1 plus 2 plus 3 plus 4. So we have to add those ratings. No, take that back. At least 4 stars. So to calculate that, we have to add 4 and 5. So we find the probability of 4 and we add the probability of 5. We want at least 4 stars. Sorry, that would be at most if that were that case. So we add all these together to get a total. So we do 797 plus 79 plus 26 plus 22 plus 35. We end up with a total of 959 ratings. So the probability of getting 4 stars was 79 out of 959 plus the probability of 797 out of 959. So that gets us a probability of 876 out of 959, which is approximately 0.9135. So there's approximately a 91.35% chance of this iPad getting a future rating of at least 4 stars. Okay. So next up, now you're told that you're going to raise alpacas in the spring. Babies are born. We have 2 different types. We have white alpacas, mixed colored alpacas. We have male and female. So the first thing you're going to do here in this table is you're going to total these columns. So we have 51, we have 39, we have 40, we have 50, and those add up to 90. Okay. So the idea here is that for part A, they want to know what's the probability that an alpaca chosen at random is of mixed color. So we look, how many mixed color alpacas are there? 39 out of the total. So the probability of choosing a mixed color would be 39 out of 90. So 39 out of 90 is approximately 0.4333. Okay. So now it says, what is the probability that an alpaca chosen at random will be white or female? So remember that the word or means that we add the probability. So the probability that it being white or being female means that we add those 2 together. So the probability of it being white plus the probability of it being female. Because it's one or the other. Okay. So when we look at that one, the probability of a white alpaca is going to be 51 out of 90 plus the probability of being a female is 50 out of 90. That gets us to 101. But here's the problem with that. The problem with that is that we've already got this. Well, that's over 1. It makes it over 1 because it's over 90. But what we can do to accommodate for that is we can subtract out the probability of white female. That takes care of the double count. So how many females were white? And that'd be 28 out of 90. So if I subtract out the 28 out of 90, that gets us a total of 73 out of 90. Which is approximately 0.8111. So approximately 0.811, 81% of alpacas will be white or female based on the information given. Okay. Now, the next question. What's the probability that an alpaca chosen at random will be white and female? So because we're looking at white and female, we're only going to look at the white female column. So in this case, it'd just be 28 out of 90. And 28 divided by 90 gets us 0.3111. So approximately 31% of alpacas born, the probability of choosing a white and a female would be that case. Okay. So now the idea is set. Now the next question says, if an alpaca is white, what is the probability that it's a male? So I want to find the probability of a male given that it's white. Okay. So what happens is because we're only looking at white alpacas, that limits us to this first row only. So of all the white alpacas, how many of them are male? Well, that's 23. So in this case, the probability of selecting a male, given that it's white, is 23 out of 51, which is 0.4510. So approximately 45% chance of selecting a male, given that the alpaca is white. Okay. So we're going to move on to question 18. So question 18 says, a sampling of professional persons at a conference provides the following data. So they want us to answer the questions based on this information. And again, it says express your answer to 3 decimal places. Okay. So if a professional person is a woman, what is the probability that she will be an engineer? So we want to calculate the probability of selecting an engineer given that this engineer is a woman. Okay. So this is our set condition. So because they only want us to select from women, we're only going to select from the middle column. And we only want to look at the number of women engineers. So that would be 256 out of 1,467. So when I divide that out, we round it to 3 decimal places, we end up with 0.175. So the probability of selecting an engineer, given that they are a woman, is 0.175. Okay. So for part B, it says, given that the professional person is a doctor, what is the probability that he is a man? So because given that it's a doctor, we're only going to select from the doctor row. So again, we want to find the probability of selecting a man given that they are a doctor. So we're only going to look at the doctor row. So how many men are doctors? 787 out of 1310. So 787 out of 1310. So that's approximately 0.601. So the probability of selecting a man, given that they are a doctor, 0.601. Okay. So now for part C, it says, if a professional person is a woman, what is the probability that she is either a lawyer or a doctor? Okay. So the given is already set. It's a woman. So we're only looking at the column of women. So we want to find the probability of lawyers or doctors given that they are a woman. So the total number of women, so our total is going to be 1,467. We have 688 lawyers, and we have 523 doctors. So if that's the case, we would add those together. So 688 plus 523. That is 1,211 divided by 1,467. Which gets us a probability of 0.825. So therefore, there's a 82.5% chance of selecting a lawyer or a doctor given that they are a woman. Okay. So then for part D, if a professional person is chosen at random, what is the probability the person is a lawyer? Okay. So for that one, because notice it says it's a professional person, that includes everybody. So how many lawyers are there altogether? 1,537. So the probability of selecting a lawyer would be 1,537 out of 3,724. Which is 0.413. Okay. So we flip the page. We go to number 19. So number 19 is false positives, false negatives. So we're told that 4% of alpacas have megaesophagus, which is a choking disease. Your vet can test for a disease with 90% accuracy, fill out predicted outcomes for 1,000 alpacas. Okay? So notice that 4% of alpacas have this disease altogether. So if that's the case, 4%, 0.04 times 1,000 will have this disease, which is equal to, just double checking, that would be 40. Our total is 1,000. So if 40 have the disease, we could do 1,000 minus 40 to get 960. So 40 would have the disease, 960 would not have it. Okay. So with that said, of these 40 that have the disease, 90% of them would test positive. So we would do 0.90 times 40 to get 36. So 36 of the 40 alpacas that have this condition would test positive. So to calculate the number of false negatives, we would do 40 minus 36 to get 4. So there would be 4 alpacas that have this condition, but they would test negative, so it'd be a false negative. Now we do the same thing for those that do not have the disease. So if they don't have the disease, 90% of them would get a negative test result. So here we would do 0.90 times 960 to get 864. So then to calculate the number of positives for those that don't have it, so this is the false positive, we would do 960 minus 864 to get 96. So therefore, 96 alpacas would produce a false positive. They don't have the disease, but they would produce positive results. So now we add these columns together. So 4 plus 864, that's 868. And then 36 plus 96, that's 132. Okay. So first question, if an alpaca tests positive, what's the probability that it has the disease? Okay. So we want to calculate the probability of it has given a positive result. So because we are looking at, they've already tested positive, we're only going to look at the positive column. So how many have it? 36 out of 132. So the probability would be 36 out of 132, which if we round it to 3 decimal places would be 0.273. Okay. So now, if an alpaca tests positive, what is the probability it does not have the disease? What is this type of result called? Okay. So we know that the probability of having the disease is 0.273. We get that from up here. So we could calculate does not have the disease. We can do that one of 2 ways. We could find the probability of does not given positive. So that would be 96 out of 132, which is 0.727. Or we could have done 1 minus this probability. That'll get us the same answer. And then what is this? Well, if they don't have the disease and produce a positive test result, that's known as a false positive. Okay. So part C, if an alpaca tests negative, what is the probability it does not have the disease? What is this type of test result called? Okay. So test negative and does. So we're going to find the probability that it does given a negative. That means we're only going to be in the negative column. So how many alpacas test negative but have the condition? 4 out of 868. So when we do 4 divided by 868, that gives us a probability of 0.005. And this is known as a false negative. Okay. All right, question 20. An online poll of 575 adults found that 71% of respondents think cursive handwriting should be taught in schools. The poll reported a 4% margin of error. So what's the population represented here? Well, it's all adults. And what's the sample? Well, the sample is how many that were surveyed. So it's 575 adults. So then use the margin of error to find the confidence interval for this statistic. Well, the poll showed 71% with a margin of error 4%. So we do 71% plus or minus 4. So when we do 71 minus 4, that's 67%, to 71 plus 4, which is 75%. So then for part D, where it says express your answer in a meaningful sentence, we can say something that says, we can say with 95% confidence that between 67% and 75% of adults think cursive handwriting should be taught in school. So again, we can say with 95% confidence that between 67% and 75% of adults think cursive handwriting should be taught in schools. 95%, or is it 9? Yeah, 95%. Okay, good. All right, so that brings us to the end of reviewing for the test. No one got on to ask questions. That's great. I will post this to YouTube, and I will post a link to the video here in a little bit. If you do have any questions throughout the week before you take your test, if you want to email me, you're more than welcome to. Otherwise, we will talk to you later.